Hi everyone, my name is Winnie and we'll continue on with the Intro to React Part 2 workshop, and let's look at data fetching. So what does data fetching mean? What that pretty much means is that with our front end or interface that the user uses to click buttons and ask for some things to be done and see actions to be performed, if they might click on a button that wants you to make a request or something of that nature to a backend, then to do that, to make a request from the front end to the backend is something that we can use fetch to help us with. So this fetch idea will be kind of like a HTTP request. If you are not too familiar with HTTP, that is pretty much a way in which we kind of make a request to a backend or a server to kind of ask it to give us information. And I really recommend you, take a look at what that means in general and how you can do different methods of getting the requests, like get, put, post, delete, and so on. We will also discuss it a bit in our backend workshop next time, but yep, so this is how we have our front end communicate with our back end. So our back end can do any function that it needs to do, return that data to the front end, and then the front end can display it perhaps to the user. And so that's why we kind of use fetch when we're making front end apps. And we also use it in React as a result. So let's go through this. Some of the things we do for with fetch is get data from a backend, because the backend might also interact with a database as well. We could also get data from an external API, which is just pretty much like a URL where we can get data from. And usually the data that is transferred from front end to back end, or the stuff that is returned from the backend, is in this format called JSON, JSON. And I recommend you look into that, but we will go through it also a bit next week. But it's pretty much the kind of standard that we look to how to send data across from one place to another. And we can get data from the backend or external APIs. With a backend, it's like something we created when we've created an app, a front end, back end, which makes up like an almost full stack, which is what we call. Or we get it from external API, which is something someone else may have made. Or we can actually send data over to modify or update or create something, and also like perform an action on the back end as well. So how do we then do that? So we use the fetch kind of keyword in JavaScript, or in, I guess, React. So this fetch idea is a built-in thing in JavaScript, and in React we can use JavaScript to perform actions and then embed it and mix it up within HTML as well. And so that's where we'll be using the idea of fetch. There are some other libraries as well. I believe one called Axios that works pretty well, especially with React, but we're just going to focus on fetch at the moment. And so what fetch does is it once you give it a URL, it could be the backend URL you want to interact with, or an external one like this. It will send a request to this URL to, like we said, we could get information, send data, and so on. And in this case, I believe we'll be getting data. And so what fetch returns is actually not the data itself yet. It returns something called a promise. And this promise is just because this is kind of telling you that we need to, once we send something or a request, we need to wait for it to be requested and then sent back. And so that's why it doesn't return immediately with the object. It creates a promise. And to actually get the data, you you need to take some extra steps. And so I guess firstly, when you have a fetch request, it can return the promise, and it can either resolve, which means it's a positive outcome. The data has been sent back. The data you want has been sent back to us, so we can use it, or it's been rejected, which means there's probably some kind of error that happened. And so in the case that it has resolved, it can resolve with a response object, which is what we wanted when we made the fetch request, something that we wanted to get from making the request to a backend or an API, external API. And so to interact with that, to wait for the request to be sent back, we need to write a .then. And so that's where we have a response object sent back. So we can't interact with the data from fetch specifically immediately because we have to wait for the data to come back to us. So we put a .then to do that. But as I said, that data that's sent to and fro is in something called JSON, which is a type of notation. And so we get that response that we received, and we want to turn it from JSON into an actual object that is a JavaScript object, not a JSON object. And so we try and convert that to JSON, but it's actually not that simple. That actually is a process where you also have to wait for it to occur. So that's why we use a .then as well. And so anytime that you have to wait for a process to occur, you know that the return value is what we call a promise. And so whenever we want to wait for the promise to what we call resolve, like I mentioned earlier, or to be finished and actually have done our thing that we wanted it to do, we always have to write a .then. And then so now we've got the response. We've converted it from JSON to JavaScript or JavaScript object. Now we can just console.log it. And so another syntax we can use if we don't want to use .then is the idea of async and await. And so when we want to wait for the fetch function to work, we can just write the await keyword in front of it instead of doing this kind of chaining idea of .then. And same in this case. So these two are equivalent. But whenever we use the keyword await, we always have to prefix the function declaration with the word async. That's just the syntax we use. So this is what fetch is all about. And so let's give it a go. So if I ran this, I'm gonna, do what we saw in the example, fetch this, and then let's try and log the actual object. So what does that look like? Here it is. So it works. It gives me, so if you actually go to that website, it should give you this data, and it gives me the data that I am looking for. Awesome. But there is a small thing, a bit of a problem. So this occurs when we're using React use state hook, when we're dealing with using fetch. So if we look at this code snippet here, let's say we want to get the data from the fetch request, and we use we use it and we not use it. We create a use state for it so we can keep track of it. So we're hoping that we can fetch and then we can get that data and then we can set the data. But the thing is, we realize that this happens so many times. And so what's happening is we've gotten the data, we've set the data, and so the state has changed. And then so we need to update again and again and again and again. So we've set the data. It's a bit of a infinity kind of loop. We set the data, so it re-renders and it runs this code again to set the data again and so on. And it keeps the same fetch request multiple times because we just keep setting the data. And so this is what we kind of see here. And then at some point, this this kind of creates I guess some cause error, which is kind of like just a security error where they just notice there's lots of requests happening at once. So this is what kind of happens if we're not really careful and we use state with fetch. And so there is a way to avoid this infinite fetching kind of happening. And yeah, so we need to really control when we send the request. We can't do it like for every single time, right? And so the main thing that usually happens is we either want to fetch data from the external source once, or when something changes from in that data. And so what we can do is use the use effect hook for this instead. So in this case, for example, we only want to fetch the data once, so we can see that because the dependency array is empty. And so so this is an example where we just want to fetch the data once. And so instead of just using use state, we want to use use effect as well. Otherwise, it will just keep infinitely looping, changing each other and making infinite requests. And so now we can just fetch it and do what we had originally and put it all in the use effect hook instead. But we also need to kind of be wary of how we use this. And so just especially in the terms of if we're using the async and await keywords. So the thing with use effect is if you make it async, that kind of means that it's making it a function, a promise function. So this is getting like a bit into like the reason why, but pretty much you just can't make this use effect function that you're passing in async. And you can this part is not as important, but pretty much is because yeah, it's kind of like meaning that this is kind of like a promise. The whole thing is a promise, and therefore, because you've put the async keyword in front, it returns a promise, and that's not allowed when you're using use effect because when you're using use effect, you can optionally return a cleanup function, but using async is like returns a kind of promise, which is not a valid cleanup function. So you can't use async and await like this syntax that we see right here. But yeah, so that's a bit of a deep dive into why we can't use it in the syntax like this. But long story short, you just can't do that. And so we can work around it though. What you want to do is make sure this function, this outer function is definitely not async. But if you do want to use async await, you can create a function inside this function, and that will be the async one. And then you do all the async await in here. And so it will just because of this, you'll create it just like that. And then as soon as you've created, so this is just defining it up here, right? So you've created the async one, but then you can do this within your use effect. You don't have to, but you can. And then once you've done that, you can call the function directly. So you've defined it, and then you call it. And that's how you kind of go around it. So we don't need to actually await this. So don't need to put the keyword await in front of it as well. It's all handled when you're in the actual function. Cool. And yeah, I mean, that's all we need, but kind of, right? So you can see in this example, like this here, we're fetching the two cards. So let's see, the first campaign, the first campaign is like for one thing with like these certain details, and this is another thing. And so what this application did was make a fetch request to the backend to get the information that's appearing here. And so we kind of saw though, right? If I play it again, we jump to the dashboard and it's empty for a moment. And then it appears. So the thing is, when you make your fetch request, of course, sometimes it does take a long time to load. And so what if you don't realize that? And so it's like blank for a while, and then you thought it's just not working or something, but it just takes a long time to load. And so we want to always be really communicative, right, when we're doing this. And so that's where we can have a kind of loading icon if we are waiting for something to happen. So this is where we can do, like we say here, a loading state. So display a loading indicator if we haven't finished fetching the data yet is pretty much what's happening. And so let's go through how to do that in this code snippet here. So we have the first bit, which is talking about the data from the fetch request. And then the next bit though is the loading. So we want to also keep track of whether it's still loading or not. And to do that, we have a use state hook. And we want to set it to true because we're going to assume that it's still loading. And then we perform the fetch request. And then once the fetch request is done, because we've used await, the fetch request becomes done here. And then the data is set correctly. So the data that we want is, or the things that we want to display on the screen as we saw before, is set. So everything from the fetch request, we got what we need. And then now we can say that it's no longer loading. So we can remove the loading spinner, and that's seen here. So if it is loading, make the loading spinner happen. So you can see this is a component which shows a loading spinning icon or component or whatever that might look like. And it's always checking the use state variable of is loading, which can be set as false when it's all loaded and fetched, or is true as the default when it's still loading. And so that's how we add a bit of communication and a bit of usability, transparency as to what's happening when we're making an app, and it's pretty important. Cool. Another thing we want to do is also let them know if there's any errors. So when we make the HTTP request, we send them some data to help them be like, oh, now I know what you're looking to ask for or what you're looking for. Let me return you some data to satisfy your request. And so sometimes it's positive. It can definitely do what you requested and send back what you need. Other times, it might not really interpret your request well, or what you're looking for is not there. And so in the response object, the thing it sends back, it can also send an error as well. So if we look here, we can respond, we get the data that we get the data that we try to fetch. And so inbuilt in that object is an okay, what's that called? Key, I think. And so if that does not exist, or if that is not okay, then we can throw the error. And to do that, we use these keywords. And this is an error object, which is built into JavaScript. So you can just throw a new error object. Cool. And so this is how we can deal with any errors. So luckily that every response based on the backend, it should have the field okay. And that's where you can check if an error has occurred or not from your request. And so once you throw an error, how do we deal with it? We can't just crash the program, right? We kind of have to handle it. And one thing, because we're at the front end, you can display an error message. And you can see that if it is error, we have a simple error message saying, oh no. So we need to keep track of if there's an error or not. And so that's why we've used another use state to check it out. And so now that we've thrown an error message, we need to catch it if there is one. So that's why we've used this kind of syntax called try catch. And so what this means is that we're going to try to get the fetch message or fetch what we want. We're going to try that. And if it doesn't work, we'll throw a new error. And so if the new error is thrown, then the catch section is run. So if there is no error thrown, this whole catch section is skipped past and everything else runs as smoothly. But yep, if the error is thrown, this happens. And this makes sense. Once we know the error is there, we can set the state to be true and then don't continue forwards here. And so this part will be if it is successful, you do put the data where you want to put it and it's no longer loading. So this is how we can also handle the errors that may occur when you're doing a fetch request. Cool. And so there's also the idea of race conditions, and what this means and what happens in this case is that you might have more than one fetch request happening, and who knows whichever might happen first. But for this case specifically, we have another example as well. So if we want to make a fetch request, we might be dependent on a specific variable passed in. And in this variable passed in, it might be quickly changing all the time. And so what this means is the X variable that we're relying on could be changing at any moment. So it could be old by the time we make the fetch request. Like the fetch request isn't what we're looking for. It won't return what we're looking for because X has already updated. So this is the case if data changes really quickly. So there is a way we can fix this. But yeah, this is the other thing that I was talking about as well in terms of race conditions. So if we had more than one fetch request happening, there's actually no guaranteed way that we can definitely tell which one will happen first. And so that's why, yeah, even though one is written here and then one is written here, one after the other, they don't have to occur one after the other. Just like in JavaScript is not a yeah, it's not a synchronous, it's asynchronous, right? So that's why sometimes, yeah, we don't know what happens first. And so to kind of help with both these cases, there's the idea of aborting requests. And so if you had some change in data or something, you can cancel your request so that you're not making an unnecessary one because you already got data changed. So to do that, JavaScript luckily has an inbuilt thing called abort controller, and that can cancel ongoing requests. And in this, to use that, we'll see here, but it's pretty much the second argument in the fetch request as well. So let's take a look at this code snippet. We can create this controller now using the keyword new and having the instance of an abort controller. And so as we set everything to loading true, we can now create the fetch request, and as the second argument, pass in the controller just so they will also be in tune with how the request is going. And so that's how you pass it in. And then you continue as normal. And then the only thing is, so this is all inside a use effect. And the only thing is, like we mentioned before, in use effect, you can return a cleanup function, I guess. And so to do that, and to link it to the fetch request, we return the cleanup function like this, create an anonymous function, and return the abort method of this. So this is how we abort the request if we need to, and that's how we use it if we are in use effect. So this is a pretty handy tool to help us not, I guess, like have so many requests. We just have we can have more control with how many ongoing requests there are and cancel any if needed. Cool. And I think that's pretty much all from us. I hope that makes sense today. And yeah, I'll stop the recording there. And please let us know if you have any questions or feedback. Thank you. I'll see you next time.